Hello everybody, this is Tao Exam Coach. Today I want to give you an interesting GMAT quantitative question. Is x the square of an integer? When x is divided by 12, the remainder is 6. And when x is divided by 14, the remainder is 2. Let's analyze this interesting question. Statement 1 says that when x is divided by 12, the remainder is 6. From the properties of integer division, that the dividend equals the divisor multiplied by the quotient plus the remainder. So considering this, we can say that according to statement 1, x can be represented as 12 multiplied by some integer quotient plus 6. If we analyze this expression, okay, we can factor here 6 that multiplies 2n plus 1. So take a look at the meaning of this expression. It is 6 multiplied by some odd number. But in order for x to be the square of an integer, multiplying 6 by this odd should be an integer square. It is impossible if you just multiply any odd number by 6 to get a square, because an odd number will never contain as a factor another 6 which would be necessary to complement a square. We would need something like this, that this number here should be 6 multiplied by some other square of an, but an odd number will never contain 6 as a factor. So it is impossible that this expression may be the square of an integer. Statement 1 alone sufficient to respond on the negative. What about statement 2? Statement 2 says that when x is divided by 14, the remainder is 2. Let's analyze this over here. X is 14 times some integer n plus 2. Let's analyze whether there are some situations where this expression can be the square of an integer. What about when n equals 1? If n equals 1, then x equals 14 times 1 plus 2, which yields 16, and bingo, 16 is the square of an integer. But what happens when n equals 2? So if n equals 2, n would be 14 times 2 plus 2, which would yield 30. 30 is no square. So to answer possible for the question above, that means statement 2 is not sufficient. When statement 2 is not sufficient, statement 1 is sufficient, the correct answer choice would be A.